Hey fifth graders, it's Mrs. Tremblay. It's time for lesson 5 in unit 2. And today we're going to continue to look at place value, but instead of looking at the left side of the decimal point, we're going to look also at the right. So we're going to kind of just take what we already know and add a little bit to that. So first things first, I want to talk about expanded form and expanded notation with this. We have to figure out how much each digit is worth in order to make this happen. So we're going to make a diagram pretty similar to what we did before with the value of each digit. So first off, let's start with this 8 right here. Now this 8 is in this is tenths, hundredths, thousandths place, right? So this 8 is not worth 8. It's actually worth 8 thousandths. All right. Now that as a fraction I could write as 8 over 1,000. Those are equivalent. This is 8 thousandths, this is 8 thousandths. Now if I wanted to write this in expanded notation, I would write this as, there's my digit 8, and I'm going to multiply it by the place that it is in. And this is in the thousandths place. Usually we use the fraction notation. That's how you'll see it. I could say 8 times 1,000th as a decimal, so 0.001, but usually you'll see it written like that. So either of these would be expanded form, this would be expanded notation. I know, so fancy, right? So let's take a look at this 4. We're going to do the same thing. This 4 is in the tenths hundredths place, so it is worth 4 hundredths. That's the decimal form. Fraction form would be 4 over 100, so 4 hundredths. And in expanded notation, I would take that digit 4 and multiply that by the place that it is in. It's in the hundredths place, so I would multiply that by 1/100th. All right, same thing with the 6. We're on roll. This 6 is not worth 6. This 6 is in the tenths place, so it is worth 6 tenths or 6 tenths. That's expanded form. Expanded notation, I'm going to write my 6 and multiply it by the place that it is in. It is in the tenths place, so I would say 6 times 1/10. The rest of this, it's going to be just like we did before. So this 5 is in the ones place. It's worth 5, right? And if I wanted to write that in expanded notation, I would take that digit 5 and multiply it by the value of the place that it's in. It's in the ones place, so 5 times 1. This 3 right here, it's not worth 3. It's in the tens place, so it's actually worth 30. That's expanded form. Expanded notation, I would take my digit 3 and multiply it by the place that it is in. And last but not least for this one, this 2 is not worth 2. It is worth 200 because this is in the hundreds place. In expanded notation, I would say 2 times 100. So if I said to express 235 and 648 thousandths using expanded notation, you would say 2 times 100 plus 3 times 10 plus 5 times 1 plus 6 times 1/10 plus 4 times 100th plus 8 times 1,000th. So very similar to what we did before, except now we have our tenths, hundredths, thousandths. All right, so let's try a few here. I have write each number using expanded notation. So that expanded notation means I'm writing each digit and multiplying it by the place that it is in. So we're gonna go from left to right with this. This 8 is in the tens place, right? So I'm going to say 8 times 10. Plus, this 2 is in the ones place, 2 times 1. Plus, this 3 is not in the tens place, it's in the tenths place. So I would say 3 times 1/10, which would be 3/10, but I didn't ask you for expanded form. I asked you for expanded notation. And that's it. And we have addition signs between those because if we actually solved this, this would be 80 plus 2 plus 3/10, and 80 plus 2 plus 3/10 would get us back to where we started. So we want this expression to have the same value as that one. All right, next, maybe you want to pause it and try this on your own. That's fine, and if not, it's fine too. Just make sure you're checking your work to make sure that you're right. I'm going to start here. This 1 is not worth 1. It's worth 100 because it's in the hundreds place. So I would express that as 1 times 100. I don't have to say 0 times 10 because 0 times 10 is 10. But I do have a 2 in the ones place, so 2 times 1. Plus, right, here's another 2, but this 2 is in the tenths place. So I'm going to say 2 times 1/10. Plus, this 5 is in the hundreds place, 5 times 1/100th. Okay, letter C. This 1 right here, it's in the ones, tens, hundreds, thousands place. So I'm going to say 1 times 1,000 plus, I don't have to do anything with those because when you multiply by 0, you'll get 0. The last digit I have is a 9. And this 9 is in the tenths, hundreds, thousands place. So I'm going to say 9 times 1,000th. Okay, now I want us to do the opposite, and we're going to go backwards. I'm going to give you the expanded notation, and I want you to write it in standard form. That means write the number. And just like before, where it was easier to start with the ones place and work our way over to the left, we're going to do the same thing, except this time I want you to look for the digit that would be farthest to the right. And we do have some tenths and some hundredths in this one. So we're only going to be working up to the thousandths place. So if I were you, I'd look for 1,000th first. And I don't see that. But the digit that would be farthest to the right, I see is right here, this 3 times 100th. So I know that this 3 is going to be in the hundredths place. So that means that I'm going to need a digit in the tenths place before I make my decimal point, right? Okay, and I do see 5 times 1/10. So right now, I have a 3 in the hundreds place, I have a 5 in the tenths place. This is the ones place, right? And I do see 7 times 1. This is the tens place, and I do see an 8 times 10. This is the hundreds place, and I do see 3 times 100. So that's it, 387 and 53 hundredths. All right, the next one, as I look, I see that 9 times 100th, that's going to be the one that's farthest to the right. So I'm going to go ahead and put the 9 in the hundreds place. Now the next one over from that would be the tenths place, right? I do not see anything multiplied by a tenth. That means I'm going to have a 0 there with my decimal point. If I didn't put the 0 there, then I'd have 9 tenths, and this does not say 9 times 1/10. This says 9 times 100th. All right, next over I would have the ones place right here, and I do see times 1, there's a 6 times 1. Then I would have the tens place. I don't see anything multiplied by 10, so I'm going to put a 0 there. And I see the next place is a hundreds place, and I see 3 times 100, so I put a 3 there. The next place over would be the thousands, and I do not see a number times 1,000, so I'll put a 0. And the next place I would have is the 10,000s place, which there's 2 times 10,000. So you should have 20,306 and 9 hundredths for that. All right, last but not least, all the way, we're going to start over here. I have 4 times 1,000th. So this 4 should be in the thousandths place. The next place over from the thousandths place is the hundredths place, and I do see 8 times 100th. The next one over before the decimal point would be the tenths place, and I do not see anything multiplied by a tenth. That means I'm going to put a 0 in the tenths place, because if I didn't, then the 8 wouldn't be in the hundredths place, and the 4 wouldn't be in the thousandths place, so it is necessary. All right, the first place to the left of the decimal point is the ones place, and I see 8 times 1. Then we have the tens, and I see 1 times 10. Then we have the hundreds, and I don't see anything multiplied by 100. And then we have the thousands, which I see 4 times 1,000. And I don't see anything else, so that's it. 4,018 and 84 thousandths. All right, you are all set for the day. Thanks for watching.